So dear students, once again we start the numericals on block diagram reduction techniques. First of all, how to reduce the given block diagram, the numerical, whatever the numerical come in front of us, which consist certain complex steps. So how to reduce those block diagram, a complex block diagram, and find out the transfer functions. So see this PPT. In this PPT there are certain rules behind the block diagram reduction technique. The first and the foremost rule we can say, if the blocks are in cascade, for example the one block gain is G1s and another block gain is G2s, then to reduce this we have to multiply them. So what is the first rule? If the blocks are come in the cascade, then we have to multiply the gain of those blocks. Similarly, if the blocks are comes in, see the next one, if the blocks are comes in parallel, means let's suppose the one block is G1 and second one block is G2. If they are in parallel, then the rule to reduce that parallel combination of block diagram is just multiply the gain of those blocks. Just add those blocks if come with the same sign, positive sign. For example, here G1s and G2s are two blocks which are in parallel in summing junction, so we just add them, G1s plus G2s. So once again I repeat, if the blocks are in cascade, multiply the gain of those blocks. If the blocks are in parallel, add the gain of those blocks. The third rule is move whenever a summing point, if we wish to move a summing point after a block, let's suppose here a summing point having a gain xs, having in the summing point there are two gains, one is input side rs and one is xs, and we wish to move that summing point just after the block of gs. So we can move it easily after the block gs, but the rule says that the gain of that particular block after which you wish to move the summing junction should also be come. So whenever we just move the blocks, the summing junction after the block, then the summing junction will again come after the block, but having the gain of that block. So what was the gain of that block? GS. So now it is come with XS. So XS, GS, and then the summing junction is represented. Similarly, if we wish to move the block summing junction just before a block, then let's suppose here in this diagram, RS is my input, CS is output, and GS is the gain of the block, and I wish to move the summing junction which have one more input of XS just before that block, then I can easily move. The rule says what was the gain before we want to move the summing junction, what was the gain of that block before which you wish to move the summing junction. So the gain was GS, so it will come in a reciprocal manner, so 1 upon GS. If it was GS, then it will come with 1 upon GS. So now see, we can easily move the summing junction before a block, but the gain of that block will become with 1 upon, means reciprocal manner. So 1 upon GS will be come here. Similarly, we can move the pick off or take off point just after the block and just before the block. So let's suppose here we just wish to move the take off point just after the block, then what will happen? The gain of that block will become with the reciprocal manner. So here the input side is RS, output side is CS, and the gain of the block is GS, before which there was a pick off point. So I wish to move that pick off point just after the block, so I can easily move that pick off point after the block, but the gain of that block after which you wish to move the summing junction will also become in reciprocal manner with that pick off point. So GS then 1 upon GS will become. Similarly, if you wish to move a pick off point or take off point just before a block, then the gain of that particular block before which you wish to move that summing junction, before which you move that take off point or pick off point will become with the gain of that block. So here it will shown. Now we want to solve some complex numerical, and here once again one more PPT is there. As rule is what the rule behind to find out the transfer function with the block diagram. The rule is forward gain divided by 1 plus or minus forward gain multiplied by feedback gain. Keep in our mind that if the feedback is positive, we have to use negative sign in the formula. If the feedback is positive, we have to use the positive sign in the formula. So let's suppose GS is the forward gain, HS is the feedback gain, and CS is the output and RS is the input. Then if, because in this diagram I put minus sign for the feedback, so if minus with negative feedback is there, CS upon RS is equal to GS upon 1 plus GS HS. Okay, so now see, let's suppose we wish to calculate the transfer function of which is shown in this PPT. A question is given, block diagram is given, we have to find out the transfer function. So I just copy this one and I will show you in MS Paint file all the rules, and now we just follow the same rules and we will do this numerical. Right. Yes. Yes. So this is a numerical. We just copy. I just copy with that MS Paint file, and we wish to find out the correct answer of transfer function. As I told you, one step by step I will show you all the rules. Now see, first of all, when I just see this question, I find that here. First of all, I these steps I will show you. So I just copy this one and just put here, so I can make any necessary changes over there, and again we will see the numerical. See, with this red color I will show you that this block diagram whose transfer function I want to find out, consists of some inner blocks. So we have to solve those blocks. We have to reduce those blocks with the help of those steps, with the help of those rules which I have already been taught you few minutes ago. So now see this one. This is a feedback loop. Is it clear? This one is a block in which forward gain. So first of all, sorry. First of all, see this G1 and G2, these two blocks G1 and G4, both are in cascade. And what was our first rule? If the blocks are in cascade, just multiply them. So what it means? These two blocks will be converted into a single block. I just put it in the topmost side, so you will understand step by step. So this G1 and G4 will be multiply and just multiply with each other. If the blocks are in cascade, just multiply the gain of the blocks. So G1 and G4, these are two blocks, G1, G4. So these two blocks will be completely removed. And only a single block will become. So I just put it here. These two blocks will be completely removed and only a single blocks will become, whose gain is G1, G4. So as step by step we solve, then we will find out the correct answer. Okay. Now see, if this is solved, now see with the green color I will show you that what we will going to do. Now because this block is solved, this block is already been solved and converted into G1, G4. The second step. What is the second step? Don't focus on the color. Okay. So now what is the second step? See with this green color, I just see this one. This one is also a block diagram which we have to reduce, where this G1, G4 is forward gain. Where this G1, G4 behave as a forward gain. And this H1 will behave as a feedback gain. This one. This one will behave as a feedback. So how can we solve this one, and with which sign this feedback comes in the summing junction? So see, with this orange color I am showing you, with this positive sign, this feedback comes. This H1 feedback comes, the output side comes with the gain H1 into the summing junction with the help of positive sign. So as per the rule, if positive feedback is there, we have to use negative in the formula. So what will be the, how we can reduce this one? Forward gain divided by forward into feedback. Again divided by forward into feedback. I just once again copy and paste so that you will understand what was our first step. So in the first step we just multiply G1 and G4 because they were in cascade. Now see, to solve this one we have to find out the transfer function of this. What is the forward gain? G1 G4, it is the forward gain. So G1 G4 is the forward gain. G1 G4 is the forward gain divided by, so this divided by 1 plus or minus, so 1 with feedback. So what was the forward? G1 and G4 is the forward, multiplied by feedback. And what is the feedback? Feedback is H1. Yes. So we just solve with the help of the last rule which I taught you few minutes ago about how to reduce the block diagram and find out the transfer function. So now this total green colors encirclement will be converted, will be solved and reduced by G1 G4 upon 1 minus G1 G4 H1. G1 G4 H1. What I want to see, this complete block diagram, this complete will be reduced. Once again at row L. One more step, so you will understand. Wait. So see, we just remove this all because we have already been solved this one, and instead of this only one step will be here, which is G1 G4 divided by 1 minus G1 G4 H1. Now once again we have to solve the next step to find out the transfer function. See, these two blocks, what is the name? Actually the name is, wait, G1 G4 G2 G3. Actually the name is G3. This one is G3. This one is 3 actually. Okay, so G3, see this one which I just in blue circle I am showing you, G3 and G2, these two blocks are in cascade. By representing by, see the question, how you can understand that these are in cascade. If the input side comes from the same point and the output will reach at the same point, if input comes from the same point and the output will reach at the same point, then it is known as parallel. The blocks are in parallel. So here G3 and G2 both comes via a single pick off or take off point and will reach in a same summing junction. So they are in parallel. So they are in parallel via positive sign. They are parallel via positive sign. So they will be add up to each other. So G2 plus G3. So they will be add up to each other as per the rule. As per the rule, second, if blocks are in parallel, then they will be add up to each other. So they will be add up to each other and will convert it into a single blocks, which I just show here, so you will understand step by step. So they will be converted into G2 plus G3. G2 plus G3. Okay. So now this block will also be removed. this block will also be removed. So this block completely removed, and now the block instead of this will be the reduced form of that question. So G2 plus G3. Now see, now the question will be reduced in this canonical form, and now these two blocks I just show you in brown color. These two blocks G1 G4 upon 1 minus G1 G4 H1 and the second block G2 plus G3. Now these two are in cascade. These two are in cascade. So I know the rule: if the blocks are in cascade, just multiply them. If the blocks are in cascade, just multiply them. So when I multiply them, so G1 G4 multiplied by G2 plus G3. So this will be further reduced such that, first of all, I just solve and will show you the value. Okay, so G1 G4, so G1 G4 multiplied by G2 plus G3 multiplied by G2 plus G3 divided by 1 minus G4, 1 minus G1 G4 H1. So divided by 1 minus G1 G4 H1, G1 G4 H1. So this one is the new representation of those two blocks which are in cascade. So this will be converted into this. This will be converted into this. See carefully. In this step, what we did, G1 G4 upon 1 minus G1 G4 H1, this block, and G2 plus G3 block. These two blocks which we have already been solved earlier comes in a cascade. So we know the rule: if the blocks are in cascade, just multiply them with each other. So when we multiply G1 G4 upon 1 minus G1 G4 H1 with G2 plus G3, then my answer is G1 G4 divided multiplied by G2 plus G3 divided by 1 minus G1 G4 H1, 1 minus G1 G4 H1. Okay, so just use this one. I just remove these two blocks completely and put a single block which was actually come from the solution of those two blocks via the block diagram reduction rules. So now these two will be converted. So step by step what we did, first of all we solved the cascade form, then we solve the first of all we solve the cascade form, then we solve a feedback loop, then blocks are in parallel, then blocks are in cascade again. Now once again see, there are two blocks, one is forward and one is feedback. The forward gain is at G1 G4 G2 multiplied by G2 plus G3 divided by 1 minus G1 G4 H1, and the feedback is H2. So I write down, this one will behave as a forward gain. Now this one will behave as a forward gain, and this one will behave as a feedback gain. This one will behave as a feedback. So what is the rule? How to find out the answer of transfer function? Very simple. Forward gain divided by 1 plus or minus forward gain into feedback gain. From with which feedback is this one? See, with negative sign it comes. The output part comes in the input side via negative sign. So it is negative feedback. So we have to use positive sign in the formula. So what is the rule? Forward gain. So what is the transfer function finally? The transfer function Cs upon Rs the transfer function Cs upon Rs will be equal to forward gain. So what is forward gain? This forward gain divided by 1 plus, because negative feedback is there, so I put 1 plus forward into feedback. So forward is the same, multiply by feedback. So multiply sign I just put. Feedback, what is feedback? H2 is only present, so H2. Okay, so when we will solve, we will finally find out the answer of this one. So we just solve this one. I just see with the purple color the answer of this one. So G1 G4, so G1 G4 multiply by G2 plus G3 multiply by G2 plus G3, okay, divided by when I took the LCM 1 minus G1 G4 H1, so that the denominator term will be 1 minus G1 G4 H1 G4 H1 plus G1 G4, see very carefully, G1 G4 when multiplied with G2 and externally H2 was there, H2 plus one more term G1 G4 again multiply with, G1 G4 again multiply with G3 and the external term is H2. Okay, so this one is the final answer of this question. So we are capable to solve this numerical because we understand all those rules of block diagram reduction and we just apply all those rules in this questions. So with the help of this question I understand that you are able now how to apply the block diagram reduction rules to solve our numericals. We can solve any kind of numericals with the help of those blocks. Okay, I am just giving you right now an example of how to see the numerical and how to keep in your mind that what the necessary steps we have to do with that numerical. So I just open one more numerical. Wait. Kind of wait. Yes. So this is your new MS Paint file and I just put a new numerical in front of you. We are not going to solve the complete numerical, but you should understand with the help of the steps that what the necessary steps we are going to do with this so that we are able to find out the answer. Now see, I am just telling you the steps. See, when we have to find out the transfer function of this question, let's suppose we have to find out the transfer function of this question in which the output is CS, input is RS, G1, G2, G3, G4, G5 are present, H1, H2 are present. Okay. Now see, when I have to solve this question, we have to solve this question whenever any question comes in front of you. Just keep in your mind all those rules which I have already been taught you regarding the block diagram reduction technique. Now see these three loops. I just encircle these three. Now see these three. This G4, G3 and G5, all three are in parallel. What is the definition of a parallel thing? If the input side comes with the same point and the output will reach at the same point. If the input side comes with the same point, maybe pick off point, and the output will reach at the same point here, like a summing junction with the positive sign here. So that is known as input comes with the same point, output will reach at the same point. It means they are in parallel. So whenever blocks are parallel, what the block diagram reduction rules tells us, just add up to each other. So G4, G3 and G5, all these three will be added to each other. So this will be completely converted into this. G4 plus G3 plus G5. Yes. Now see, again in this question, see this G1 and H1, this is F and forward gain are present. So how we can solve them? If the forward gain is G1 and feedback gain is H1, then these blocks will be completely reduced with the help of this. Forward gain divided by 1 plus or minus forward into feedback. We know what is the forward? Forward is G1. We just see it in a fast manner because we already been understand the rules. So G1 is the forward gain divided by with the negative sign it comes. So in formula we have to use the positive sign because negative feedback is there. So 1 plus forward into feedback. What is forward? G1 is forward, and what is feedback? H1 is feedback. So G1 H1. Okay. So this completely reduced by this one. Yes. So what it means? The given question. Sorry. Yes. So the given question will be now converted into this, reduced into this form. Once again I will copy and paste that question here, and I will tell you what are the changes which we have already been done. So we done that these three blocks will be completely removed. These two blocks will be completely removed, forward and feedback, because we have already been solved them. These three blocks will be completely removed by this one. Wait for a while. Yes, the G4, G3 plus G5 is there. Yes, and that feedback will be reduced by this one. Yes. So now the question is changes completely. Now what we have to do? Now again see the question which you just reduced right now with the help of that cascade combination and that rules, with the help of those rules which you apply right now. Now what will happen? See, now these three blocks comes in cascade completely. See with the green encirclement, this block, the second block and the third block, both of these three comes in cascade completely, and we know the rule of cascade. Just multiply them with each other. So we just multiply G1, G2. So what will happen? It will be reduced in the form of G1 multiplied with G2, which is further multiplied with G4 plus G3 plus G5, G4 plus G3 divided by, so divided by 1 plus G1 H1, 1 plus G1 H1, 1 plus G1 H1. Yes, so this completely reduced by this one. So what we have to do? I again show you the same thing. This was my question. When I going to start with that question, I just solved and find out that these blocks will be completely removed, which I just removed right now, and find out the solution as this one. Now what I have to do? Now see, there is a feedback. Now see very carefully. There is a feedback with this red circle. Just see this one. Just see this one. This one is a feedback loop. In which the forward gain is this one, G1 G2 multiplied by G4 plus G3 plus G5 upon 1 plus G1 H1, and feedback gain is H2 and comes with the negative sign. So what we have to do, we know the rule, forward gain. So what is the forward gain? Forward gain is this one. Wait. So forward gain divided by 1 plus or minus. What is the feedback sign? Because it is negative feedback, so we have to put the positive sign. So 1 plus forward into feedback. So what is forward? Forward is this one multiply by feedback. What is feedback? H2. So just H2 is also come with the upper side. Okay. Yes. Then what will happen? So we have to solve this one. So what is this? When we took the LCM, G1 G2 upper side will be this. This one will equal to G1 G2 upon this, and then when I took the LCM will be cancelled out from the denominator term of the upper side. So 1 plus G1 H1, as you very well known about the mathematics, 1 plus G1 H1 plus G1 G2 G4 H2 G1 G2 G4 H2 plus G1 G2 G3 H2 G1 G2 G3 H2 plus G1 G2 G5 H2 plus G1 G2 G5 H2. Yes. So this will be the new representation of these two. This will be the new representation of these two. Yes. So now this block will be completely converted. See, this is completely converted into this. Still we do not find the complete answer, because once again I show you. Now I remove all those previous steps. Now I just come with the question again and show you that these are completely removed. These are completely removed. These steps are completely removed, and only one short form of gain is coming in between them, and that is this. Now what will happen? Again, these two blocks come in cascade. These two blocks, this one and this one, are in cascade. So what will be the final answer of CS upon RS? CS divided by RS is equal to now, as we know the rule of whenever the blocks are comes in cascade, what we have to do? Multiply the gain of them. So when we multiply both the gains of these, the first gain is this one. Wait. Multiply by the second gain G6, multiply by G6, and whatever the answer of this, that will be your final answer. So we are able to solve some complex kind of numerical with the help of block diagram reduction techniques. Thanks for watching my video. Thank you very much.